things before we start solving problems. So this section is about two special cases of rigid body motion. Okay, the first one is translation. Well, actually, rectilinear translation. So in this case, the rigid body translate, but you can represent the translation along the x or the y axis. Okay, there's no rotation, there's just translation. In this case, what we have is what we've done previously in the case of particles. The net force in the x direction is mass times acceleration. The net force in the y direction is mass times acceleration. And then there's a third equation which is only true for rigid bodies. Okay, rigid bodies have a shape and size, and particles do not. They are just point masses. We got to use the moment equation. Okay, this is the same moment which you learned in statics, the prereqs for this class. You got to find the effect of the force which causes a rotation, but you take the moment about its center of mass. So center of mass. The other special case is rectilinear motion, but it's for curvilinear motion. So rectilinear, we call this, sorry, my bad, curvilinear translation. Okay. So only difference here is when the particle moves from point A to point B, it moves not along the xy axis, but it moves along a curve. Okay. So because it moves along a curve, the best way to write the equations is, well, the same equations are true, but we will write the equations in the nt coordinate frame. Ft is mass times acceleration in t, Fn is mass times acceleration in n, and then the third equation remains the same. It's the moment about g is 0. Okay, so essentially the same thing, F equals ma, but you got to look at it in a different coordinate frame, the nt coordinate frame, just because it is now moving along a curve. So what's at? It is omega square r, and an is alpha times r. Okay, any questions on that? Okay, let's follow this up with problems. Oh, by the way, really forgot. So this is extension of the recipe we've been using to solve these kinds of problem. The same things hold here, which is first draw a free body diagram and show all the forces, and that's very important. Otherwise, you will get the equations wrong if you do not show all the forces. Write the equations. The only change from chapter 13 is that besides F equals ma, we also write mg is equal to ig alpha. Well, in this case, it's ig mg equals 0, right? Because the rigid body is just translating; it is not rotating. We'll actually look at the case next section where it's actually rotating and it become more interesting. And then finally, and this is optional. This step is optional. Sometimes you're asked to find velocity or angular velocities, in which case you got to take the equation particularly this equation, and integrate that with respect to time, or sometimes displacement, to get velocity, position. Okay, so the same recipe, but rigid bodies. Okay, let's read the question. So the jet aircraft has a total mass of 22 capital mg, which I think means 22 times 10 raised to 6 gram, which is 22 times 10 raised to 3 kg. Okay, oh, it's 22 tons, and a center of mass at G, that's shown here. Initially at takeoff, the engines provide a thrust of 2T equals 4 kilonewtons, and T prime, which is 1.5 kilonewtons. Okay, determine the acceleration of the plane. Okay, acceleration, and the normal reaction on the nose wheel. So this one, NA, and each of the two wings located at B. So we got to find the normal reaction here too. Neglect the mass of the wheels, and due to the low velocity, neglect any lift caused by the wings. So first of all, when you see this problem in, say, the finals, you will not know where it comes from. The way to figure where it comes from is, first of all, notice that you ask for forces, you're given forces, so it's a kinetics problem. The second thing to know, it's a rigid body, right? You've told that this force is applied at a particular place, 2.3 meters from the ground and 2.5 meters from the ground. That means that you got to use the moment equation to solve this. So this is a problem which involves kinetics and rigid bodies. So it's a question from chapter 17. So once you know that, let's use the recipe which I just talked about. First, draw free body diagram. Okay, so you do not have to draw the plane. You do not have to show artistic skills. You can just draw a box. That's fine. As long as you show the forces right, it should be good. Okay. But if you want to draw the plane, please draw the plane. No extra points though. Okay, so that's where the gravity acts. So mg, and then T prime 2T. Okay, since the plane is we fled the plane from being in contact with the ground, we have to replace the effect of the ground with forces at the wheels. So NA and NB. Okay, now one question which I always get, people come to my office and they ask me, well, there are two wheels here, so shouldn't you write 2NB? You could write 2NB, in which case, if you write 2NB, that's fine. What I normally do is I just write NB, I get the force, I solve for NB, and I then divide it by 2, so that I know the forces on each of the wheels. So you can go either route, it's the same thing. Okay, is there any other force I'm missing here? Friction. Okay. Okay, they have not told anything about friction, but if you're not told anything about friction, just assume there is no friction. Okay, if there was friction, they would have told you, most likely they told you that the coefficient of friction is so and so, in which case you'll have to put it there, but no friction in this case. Okay, so I think we're all set to write the equations. I'm just going to complete this by drawing the distances, so it becomes easy to take moments. 6 meters It's 2.3. Oh, it's from the ground. My bad. Okay. Okay, so next step is to use Newton's law, so equations of motion. Okay, so I said there are two cases: rectilinear motion and curvilinear motion. So in this case, the plane is going to move in the x-y direction, right? So it's going to be rectilinear motion, which means that I need to choose a coordinate frame which is x and y. So let me write F equals ma in the x direction. So all the forces in the x direction, or the external forces, are t prime, 2t, and since there's no friction, that's about it. So that is equal to mass times acceleration. Net force in the y direction is mass times ay. So now I would have nb, that's positive because it's upwards, na, which is positive, it's upwards, mg is downwards, equals, so what's the acceleration in the y direction? It's 0, right? So the plane is only moving, it's only translating in the x direction. You're not at the point where the plane is flying in the air and it's accelerating upwards. Okay, so normally in the previous chapter, chapter 13 on particles, we would stop there. We would write F equals ma in the both directions. How many unknowns are there? So let's see how many unknowns are there in this problem. So there's A, there's NB, and there's NA. Okay, so there are three unknowns. You're told to solve for all three. You cannot solve for two unknowns using two equations, which means that you've got to generate a third equation. So that's where this chapter is different from the previous chapter, where you got to use the third equation in order to solve for the third unknown. The equation is moment about g. Okay, this is g. That's equal to 0. So let's write moment about g. So let's try to find the moment due to, let's take the easy ones, NB. So NB acts upwards, and it's about 3 meters from G, right? 3 meters and NB acts upwards. So you got to write the magnitude, which is the force times the perpendicular distance, 3 from G. And then you got to write the sign. Now, the way I like to write the sign is, if you hold the plane about G and you apply force NB, right, that would cause the plane to, well, the thing to spin in the clockwise direction, or the force is acting in the clockwise direction. So clockwise forces are negative, so that's negative. So next force is NA, that is the perpendicular distance is 6, so NA times 6. Okay, again do the same thing, which is hold the plane at G and apply the force at NA, and that will cause the plane to tip in the counterclockwise direction. So the force is positive. So there are two more forces, this T prime times the distance from, it's this distance. So what's that distance? So it's 2.5 minus 1.2, right? 2.5 is this point, and then 1.2 is that distance from the ground. So it's 2.5 minus 1.2. So somebody said 1.3, that's right. So what's the sign? Is it positive or negative? It's negative because, again, if you hold the plane at G, and that force is slightly above g, so it will cause a moment which is in the clockwise direction, so negative. And then 2t okay, so then there is 2t, so that's going to be 2.3 minus 1.2, similar to the previous one, 2.3 minus 1.2, and you can see that 2.3, that force 2t is acting above g, so it's going to cause a clockwise moment, so that's minus 2t times 2.3 minus 1.2. Okay, so in this equation again we have two unknowns. Okay, so right now we have three unknowns and three equations. Three equations and three unknowns. Unknowns are A, and B. And clearly, if you have three equations, three unknowns, you can solve for A and B. In fact, you can easily solve for A here because you know T prime and 2T. Once you get that, you'll have two equations, two unknowns, and that's super simple to solve, right? Because you can sub in the value of NA here and then solve for NB. So I'm just going to give you the final answer. The acceleration is 0.25 meters per second square. NA equals 73.38 kilonewtons, and NB is 142.44 kilonewtons. Now, what does the question ask you for? It asks you for, so it asks you for the force on both the wheels. So it's asking you for the sum. So it's asking you for NB. If it asked you for the force on each of the wheels, of the rear wheels, then you'll take the half of that. So it's about 72.22 is the force on each of the wheels. But this is what is asked. So that is the answer. Any questions? Yeah. Oh, so nothing will change. I'll solve the problem as it is. I'll reach the point where I find NB. But that NB in this view is just NB, that NB is shared by both wheels. So I'll just take half of that. So if I had asked you find the reaction force on each of the two wheels, I'll just take NB divided by 2, and that is the forces on each of those two wheels. That's it. Any other questions? Okay, reactions at both wheels. And the acceleration of the cart. The mass center of the cart is at G. So we asked to find NA, NB, and acceleration. So very similar to the previous problem, right? We asked the same three things. The only difference perhaps is the fact that the force is not acting horizontally, but it's acting at an angle. So again, how do you know this is from this chapter? You're asked to find forces, so it's a kinetics problem. You're given dimensions for the body, so it's not a particle problem. So it's not chapter 13, but it's chapter 17. Okay, so we got to use the recipe I talked about. First, we draw the free body diagram. So NA and NB acts upwards. Force P is at an angle of 30 degrees. And then finally there is mg acting downwards. Okay. Now you're not told anything about friction, so just assume there's no friction. This makes your life easy. So let's set up the equations of motion. Okay. Now this particular cart is moving along the x-axis. So this is a rectilinear motion problem. It's not a curvilinear motion. So we got to use x, y to describe the acceleration. So F equals ma in the x direction. So all the force in the x direction. What's the force due to P? Is it P cosine or P sine 30? P cosine, right? P, if you take the, if you want the force in the x, it's P cosine 30. So what's the sign on that? It's negative because my convention is x is positive to the right. Is mass times the acceleration of the cart. Next equation is F equals ma in the y direction. So now I would have P sine 30 degrees acting upwards. So it's positive. There is NA upwards, NB upwards, and then there is mg downwards equals mass times acceleration in the y direction, but the acceleration in the y direction is 0, so it's 0. So again, ask yourself, what are the unknowns? Acceleration is unknown. Is P an unknown? Well, P is given to us, so P is given, so NB and NA is unknowns. mg is given. All this is given. So we have two equations here, and there are three unknowns: acceleration, NA, and NB. So we cannot solve this using those two equations. So we need to generate a third equation. So that third equation comes from moment equilibrium about g. So let's take moment about g. Let's start off with the easier forces. So NA times the distance, the normal distance, right? This distance. That's 0.3. Okay. What's the sign? If you hold a cart at G and apply the force NA, it has a tendency to tip the cart. You're assuming that's the only force applied, so that's negative. NB times this distance is the moment due to NB about G. And again, if you hold a cart at G, apply the force NB, it's going to tip the cart in the counterclockwise direction, so that's positive. So what's the moment due to mg? It's 0, right? It's 0 because mg passes through g. What else? We are left with p. So what I like to do is, if it's a force which is acting at an angle to the x and y axis, I just resolve it along the x and y axis and then take the moment. So let's find the force in the x direction. That's p cosine 30. And the distance we're interested in here is the distance from this to this. So that's 0.4 minus 0.3. That's 0.1. So times 0.1. What's the sign? It's positive. So again, if you look at P cosine 30, it's acting this way. So if you hold the cart at G, that force is acting this way. So it's going to turn the cart in the counterclockwise direction. So it's positive. And then P sine 30 P sine 30 degrees. So that's going to act this way. The distance is this. So what's that distance? Is it 0.38? 0.38. It's this plus this. So 0.38. And what's the sign on that? It's negative because again, hold at G, and if you apply force P this way, it's going to turn the cart in the clockwise direction, so negative. So this whole thing is equal to 0. So NB is an unknown, NA is an unknown, P is known, P is known. So 3 equations and 3 unknowns. We can solve for the 3 unknowns. So let's call this 1, 2, 3. So 1, 2, 3 are the 3 equations and 3 unknowns, which are A, NA, and B. Okay. Okay, so essentially you can use the first equation solve for A, because everything is known except A, and then you can use these equations and solve for NA and NB. You can sub in the value of NA and B over there. Again, when you're doing this for exams, here's what I recommend. If you write up to this point and just write this statement, you'll probably get 80% of your credit. Last 20% of your credit is actually to solve for NA and NB. So if you're in crunch of time, and in fact, the term exams there's a crunch in time, just stop here. Solve the other questions. If you have more time, come back and solve this. But this will get you majority of the points. So let's if you plug in the numbers, the acceleration comes out to be 4.33 meters per second square. That's indicating that the acceleration is not in to the right, but to the left. NA is 113.4 and NB is 325.2 newtons. Yeah. Oh yeah. Thank you. Anything else? Any other questions? Okay. Let's do the last question. Yeah, I think I can be done pretty much early. I won't take 9 minutes to solve this. Okay, so the figure is the same. The things which are asked are slightly different. So determine the largest force, so P max, that can be applied to the 60 kilogram cart without causing one of the reaction wheels either at A or at B to be 0. Also, what is the acceleration of the cart? Okay, and it says you're going to find the maximum force. So what's going on here is when you keep increasing P, right? You can find for every P, you can find NA and NB, right? For the previous problem, I had given you a P and you found NA and NB. This question, you're told to find the maximum P. So if you start looking at the P values, you see that, sorry, the N values, N and NB, you'll see that as P increases, one of those will turn out to be 0 before the other one goes to 0. So you're going to find the largest value of P when that happens. Okay, so this problem actually is very similar to the previous problem, except that things are swapped. So what you've got to do for this problem is you essentially use the same recipe. So I'm going to just copy paste what I did in the previous problem over here. We just change how we go about solving this problem. So I'll tell you that what I mean by that in a bit. So I'm going to copy paste whatever I did in the previous problem over here, all the steps, except the way we solve it is going to be different. So let me just do that. Okay, so if you proceed like you proceeded previous when you get this three equations. Now what's going on here is there are, well, A is an unknown, P is an unknown, and A is an unknown, and B is an unknown. Okay, so we have in this case four unknowns but three equations. We're not given P either, right? But we're told that we got to find the largest P which will cause one of those two forces to go to zero. So we'll look at two cases. First case, we'll assume Na to be zero. Okay, so we will assume, so case one, assume Na equal to zero. So once you assume Na equal to zero, one of the unknowns gets out of the way and you have three equations and three unknowns. So you can solve for P, A, and NB. Okay. Now we have, this gives me three equations and three unknowns, NB, A, and P. So I go ahead and solve for those three unknowns. In fact, I'm only interested in solving for P. Solve for P, right? So P comes out to be, so I have 6.38 times mass times gravity. So I solved it in terms of mg. Okay, I didn't put the value. So you know m is 60 kilograms and g is 9.81. The case 2 is assume nb equal to 0 and then solve for the three unknowns. So three equations, three unknowns, na, a, and sorry n, yeah, na, a, and p. So solve for p. P comes out to be 0.97 mg. Okay, so when Na is 0, P is this. When Nb is 0, P is that. So which of the two is the largest of the two P's? Is this one or this one? Case 1? No, it's case 2. Because once the force reaches 0.97, one of the reaction forces has gone to 0. So now this body is, the cart is tipped. So before it can even reach there, this is not going to hold on to the ground. It's going to be tipped. So this is the largest one. Not because, even though this is less, this is the largest one the cart can bear before it tips. So the largest P is this. The largest force before cart tips. Okay, so given that force, we can find that force. It comes out to be 571 newtons. So this is just plugging in the value of mg, and nb okay, hold on, I think I swapped these, my bad. This should be first one, my bad. Okay, this should have been NB. I just copied it wrong from my notes. So this will be NA, and this should have been NB, NA, sorry, and this should be NB. So so this is the, again, this is the same case holds true. So P is 571 newtons and NB comes out to be 299.48. Okay.